Hi everyone. Today we're going to be starting our chapter that is going to be largely about graph sketching. And so what we're going to be doing is using information that we have about a function, either from its equation or its graph, to find out some information about that graph. And ultimately we'll be using that information to sketch a graph of a function. Now a lot of what we talk about should be pretty familiar from when we did our work with position, velocity, and acceleration. So hopefully some of this you'll find is pretty familiar. So the first thing when we're talking about graph sketching that we need to know about is something we call critical points. And critical points are just places where the derivative y prime is equal to 0 or where the derivative is undefined. Okay, so where it's equal to 0 or where it's undefined. So if we're asked to find the critical points, there's three different things we might do depending on what information we're given. So the first option is if we're given the function f of x. So for example, if f of x equals 2x to the fourth minus 4x squared, it wants us to find the x coordinates of, it should be of here, the critical points. So we know it's going to be where y prime is equal to 0 or it's undefined. Now since this is just a polynomial function, we know those are continuous everywhere, so that derivative is never going to be undefined. So I'm going to go ahead and find out where that derivative, f prime of x, which is going to be 8x cubed minus 8x, and I want to know where that's equal to 0. So I can factor out an 8x. Okay, and so now I know, I could go one step further here. I know x squared minus 1 is x squared, or excuse me, x plus 1 times x minus 1. So my critical points are at x equals 0, negative 1, and 1. And since it just asks us to find the x coordinate, we don't need to worry about the values of those critical points. So again, if we have a function, we're just finding the derivative and setting it equal to 0, and those x values will give us our critical points. Now, the second option is they may give us the graph of f of x and ask us the same question, so to find the coordinates of the critical points. Now, we know we said we found this by finding where the derivative is equal to 0. In this case, what that's really asking us is where is the slope of the tangent equal to 0? So I know I'm looking for points where I would have horizontal tangents. Right, which we know are going to occur at those max and min values. So here I know I would have one at negative 1, at 0, and 1. So I still get the same values. It's just that I'm looking at some different information. So my critical points, I'm going to put them up here. X equals negative 1, 0, and 1. Now the last way we might be asked to find this is actually if we have the graph of f prime of x. So here we're given the graph of f prime of x and again asked to find those critical points. Again, we said to find the critical points, it's where f prime of x is equal to 0. So in this case, since we're given f prime of x, we know we're looking for the zeros of this graph. So my zeros are here at negative 1, at 0, and then I cross again at 1. Now, one thing I do want to bring up, we know that we're either looking, we said where y prime is 0 or y prime is undefined. Again, since I don't have any corners, cusps, or discontinuities here, there's no places where that would not be differentiable, so that's why I didn't worry about this second case here. So that's the first bit, is just knowing where to find those critical points. Next thing we're going to look at is increasing and decreasing. Okay, we know a function is increasing if it has a positive slope. So I'm going to make a note here. We know that's if f prime of x is greater than or equal to 0, and we're decreasing if it has a negative slope. So in other words, f prime of x is less than or equal to 0. Again, we can have this question presented in three different ways. The first way they could present it is to give us the function f of x and ask us to determine where the function is increasing and decreasing. Now, you'll see the work we do here is very much the same as when we were given position and asked to find where that particle was moving right or left. We found the derivative and then we did our number line to do that sign analysis. And we're going to do the same thing here. So increasing or decreasing, I know I have to find that first derivative. That's going to tell me that information. And I know this is 8x cubed minus 8x. I'm going to find where that's equal to 0. Since we just did that work up above, I know those critical points, those x values were -1, 0, and 1. So again, just like we were doing with velocity, we're going to make our number line. So I know here I'm working with f prime of x. Now my domain in this case is from -infinity to infinity, so I have -infinity. I'm going to make a mark at -1, 0, 1, and infinity. And I'm going to test points to fill in this number line. So it may be helpful. Let's see if I can fit this here. Okay, here we go. Again, this was just x, so we don't get confused. So if I want to know between -1 and -infinity what the sign is, I might pick a -2. I'm always going to go back to that factored form. So a -2 is going to give me a negative factor here, and a negative factor here, which is going to make a positive, times another negative is going to make that whole product negative. So my sign here is negative. Now, between 0 and -1, I can do -0.5. So here I would have a negative. My next one is going to be positive now. My last factor is negative, so that's going to give me a total positive product. And I'm just going to keep going in the same way. 0.5 is going to give me a positive times a positive times a negative, so that product is negative. And then anything greater than 1 is going to make that product positive. So now, based on those signs, we said we're increasing where the derivative is positive. So I know that I am increasing on the interval from -1 to 0 and 1 to infinity. Again, just like when we did our work before, we're working with the first derivative here, so I'm working with closed intervals. And then decreasing, I'm looking for where I'm negative, so -infinity to -1. And then between 0 and 1. So again, the work here really isn't different. It's just we're calling it something different. Okay, now we're going to look at option 2. Again, we have the graph of f of x, and we're asked to find where the function is increasing and decreasing. Now, for increasing, right, we said that happens where f prime of x is greater than or equal to 0. So that means it's where the slope of f is positive. So I can see that happens here. So I'm increasing from, let's see, -1 to 0. And I'm increasing again from 1 to infinity. And then decreasing obviously is going to be just the opposite. Right? Decreasing, we said where f prime of x is less than or equal to 0. So now we know it's where the slope of f is negative. Hopefully that's not too hard to see. There we go. So slope is negative here. So I'm decreasing from -infinity to -1, and then again between 0 and 1. Okay, and then last we can be given the graph of f prime. Again, we're being asked the same questions. So if I'm increasing, right, we know that's where f prime of x is greater than or equal to 0, where it's positive. So I'm looking for the graph f prime of x to be above the x-axis. Again, you guys have done this analysis before. So if I'm looking at f prime of x, I see that it's above, so increasing from -1 to 0, and then again from 1 to infinity. And decreasing then, I'm looking for where f prime of x is below the x-axis, and I can see that happens here. Oh, excuse me, down here as well. So we're decreasing then from negative infinity to negative 1, and then again from 0 to 1. Okay, so now that we've gone through that, we're just going to run through some examples, kind of one of each. One where we're given the function, one where we're given the graph of f, and then one where we're given the graph of f prime to answer these questions about critical points and increasing and decreasing. So first, here's our function. So let's go through this. The first thing I know I have to do is find the derivative, f prime of x. And I know that's going to be 3x squared minus 12x plus 9. I'm going to find out where that's equal to 0. So to make my life a little easier, I'm going to factor out a 3. And then this is going to factor nicely for us, x minus 1 times x minus 3. So now I know my critical points are at 1 and 3. Okay, so now we're going to do our number line. Again, we're looking at f prime of x. I have negative infinity. My critical points are 1 and 3. And my last interval is between 3 and infinity. So now we're going to test some points. So I can choose 0 here. If I plug that in, I have a negative times a negative, gives me a positive for that interval. Between 1 and 3, I can pick 2. So I have a positive times a negative, which makes that product negative, and then anything greater than 3 is going to make my product positive. So now I'm increasing. Oh, I wasn't paying attention here. Sorry, guys. It actually specifies an interval, so instead of this being negative infinity, this should have been negative 1. And here at my other endpoint, it's 5. I should have paid more attention there. So now my increasing just over that specified domain is from negative 1 to 1, and then from 3 to 5. And then I'm decreasing from 1 to 3. Okay, next we have the graph of f of x. And again, just the same questions. So now my critical points I know are going to be where the derivative equals 0, so any horizontal tangents, as well as points where that derivative is undefined. So if I'm looking here, I have a horizontal tangent here at negative 3. That derivative would be 0. As I'm moving to the right, at negative 1, I have a corner here, so my derivative would not exist. So that's another case where I have a critical point. Again, I see that same kind of thing happen down at x equals 2. The derivative is not defined there. And then at 4, I have another horizontal tangent. So those are my critical points. Now, increasing and decreasing is really easy on the graph of f of x. So if I'm increasing, I'm looking for a positive slope. So I see that happening between negative 3 and negative 1. I also have a positive slope from 2 to 4. And then decreasing, I'm looking for that negative slope. Again, I'm assuming I'm on a closed interval here, so we'll assume these have definite endpoints there. So then decreasing, I have a negative slope from negative 4 to negative 3, from negative 1 to 2, and then again from 4 to 5. Okay, so then our last case here is if we're given f prime of x. Now, I know my critical points are where f prime of x is equal to 0. So I'm looking at the zeros of my graph here. So in this case, I have zeros at negative 2, at 0, and at 2. Okay, increasing is where my derivative is positive. So here I'm looking above x. So I see I'm above x from -3 to -2. And then actually over this whole interval, I'm above the x-axis, so from 0 to 3. And now decreasing is where my derivative is less than 0, so where it's below. So I see that's happening here from -2 to 0. So today we just focused on information that we can get from that first derivative. When we come back tomorrow, we'll be looking at the second derivative to see what information we can get about the function. So tomorrow we'll practice with this, and then we'll move on from there.